Greetings everyone and welcome to this new video on hierarchical, forced entry and stepwise regression. When predictors are completely uncorrelated, the order of variable entry has very little effect on the parameters estimated. However, we rarely have uncorrelated predictors, and so the method of variable entry has consequences and is therefore important. When all other things are equal, using hierarchical regression, where we select predictors based on past work and decide in which order we have to enter them into the model, makes the most sense. Usually, entering known predictors from other research into the model first in order of their importance in predicting the outcome should be done. After having entered known predictors, you can add new unknown predictors into the model simultaneously in a stepwise manner or hierarchically, such as entering the new predictor suspected to be the most important first. In the forced entry method, we force all predictors into the model simultaneously. Like hierarchical, this method relies on good theoretical reasons for including the chosen predictors, but unlike hierarchical, we make no decision about the order in which variables are entered. Some researchers believe that this method is the only appropriate method for theory testing because stepwise techniques are influenced by random variation in the data and so seldom give replicable results if the model is tested. The final option is that of stepwise regression, which is generally frowned upon by statisticians. This is because the stepwise method bases decisions about the order in which predictors enter the model on a purely mathematical criterion. In the forward stepwise model, the computer searches for the predictor out of the ones available that best predicts the outcome variable. It does this by selecting the predictor that has the highest simple correlation with the outcome. If this predictor significantly improves the model's ability to predict the outcome, then it is retained and the computer looks to add a second predictor from the available pool of variables. The next predictor the computer tries will be the one that has the largest semi-partial correlation with the outcome. That is, the computer looks for the variable that has the largest unique overlap with the outcome. This variable is retained if it significantly improves the fit of the model. Otherwise, it is rejected and the process stops. If it is retained and there are still potential predictors left out of the model, they are reviewed, and the one with the largest semi-partial correlation with the outcome is then entered, evaluated, and retained if it significantly improves the fit, and so on, until there are no more potential predictors or none of the potential predictors significantly improves the model if it is entered. The stepwise method is the same as the forward method except that each time a predictor is added to the equation, a removal test is made of the least useful predictor. Here, the regression equation is constantly reassessed to see whether redundant predictors can be removed. The backward method is the opposite of the forward method in that the model initially contains all predictors and the contribution of each is evaluated with the p-value of its t-test. The significance value is compared against a removal criterion, which can either be an absolute value of the test statistic or a p-value. If a predictor meets the removal criterion, that is, it does not make a significant statistical contribution to the model, it is removed and the model is re-estimated for the remaining predictors. The contribution of the remaining predictors is then reassessed. Hence, the stepwise criteria should not be used because they are at the mercy of sampling variation. That is to say, a particular variable might have a large semi-partial correlation in your sample, but a small one in a different sample. Hence, these methods are less likely to generalize across samples. Moreover, your sample size also affects the model you get. Furthermore, there is a real danger of overfitting or underfitting of the model. For these reasons, stepwise methods are best avoided except for exploratory model building. That's it for this video. Thanks for watching and I'll see you in the next video on output.